Codesignal, Arcade, Different Squares. Hello everyone, my name is Joshua and I'll be solving different squares by Codesignal. Let's begin. So we're given a rectangular matrix containing only digits and we're going to calculate the number of 2x2 squares in it. So for example, we have this huge matrix here, but we just want to have the number of different squares that you can encompass by using a 2x2 window. And you can see all the different iterations, but it totals up to only 6. Even though there might be some repeats, it really just is up to 6. So in this case, I think it's pretty straightforward. So we want to iterate. Here's my plan. First step, we want to iterate left to right and up to down to, left to right and up to down. That's the first step you want to do. And we don't want to go iterate all the way because we'll be doing a 2x2 matrix. So when I say that, we'll be we'll capture a 2x2 window of data from the matrix. So we only want to deal with each 4 sets of data right here. When we go try to find a number of different squares in it, I think these squares could overlap. I think that's an assumption with it. I don't think they were explicit with the constraints that much. Now to continue on, let's see here. I also want to, I think I should have put this in a precondition step. I want to create a hash set. And now you might be wondering why. So we'll be returning the number of different squares. Now the idea of the hash set is that there'll be no duplicate values in the hash set. So you could probably infer what I'm thinking. When you go through this matrix, I want to create some sort of string that is with this particular pattern. The string will be comprised of top left, top right, bottom left, bottom right digits, and I'll put it in a hash set. And I'll keep adding it into it, and if they're duplicates, it will not create an additional index with that value. As a matter of fact, there's no duplicate values in a hash set, so it's going to remain the same size when it happens. Now, when you use this window to go and iterate through this whole matrix, creating that string of the values based on that 2x2 window and add it to the hash set, you're going to find a number of different possible strings in that hash set. And that number of different possibilities will be the size of the hash set, and that also means that there's a number of different squares in it. I think you'll understand more once I implement it. So return size of hash set, which is equivalent to number of different squares. I think I should be more specific with this one, 2.1. When I captured that window of data, I'm really saying I'm going to encode it as a string val for the hash set, for adding into hash set. Okay, let's begin. So first we're going to create that hash set. So first set, it's going to be a string. Let's see, I'll call it square tracker equals new hash set. Now we want to iterate from left to right for int. I'll call this first, since in this kind of matrix you kind of go up to down. First we go left to right, so I'm going to do u to d and u to d. The constraint with this one is that since that's a 2x2 matrix, and I really just want to go, I think I'll stop like at least 1 before the ending of that whole size of the matrix, whether it's up to down or left to right. I would do u to d matrix. I think I'll make this more explicit actually, so that you guys can understand where I'm going with this one. The height of this is matrix.length, and the width is going to be matrix.length right here. There we go. Now you can see here will be a height -1, so it won't go out of boundaries. Alright. Now I want to capture a 2x2 window of data. I want to use a helper method so this will be easier to understand. When I capture this, I want to make sure that that value will be a string at the end. So I'm going to return a string when I capture that window of data. I think I'm going to create an encoding value first actually. What this encoding does is that I'm going to grab, let's see here, this encoding is going to take in into top left, into top right, into bottom left, into bottom right, and it's going to return plus. You know, I don't really need this string. So what I really want to do is make this a string. So by doing this, I'm inherently making this a string. value. All right. And this encoding value is going to depend on get 2x2 window. And that's going to take in, I'm going to take in the grid itself. So I'm going to say the grid instead of matrix. It's kind of a long name. I know it's a few characters, but you know what, just to keep it consistent so you guys won't get confused, I'll just call it matrix. And int, let's just call it x position to y position. And it's going to encode that value, so it's going to return the encoded value of that matrix. And it's going to take in, let's just say, x position, y position. That's going to be the top left. And then I'm going to copy this value so that I can repeat this multiple times. And now this time it's going to be various positions. This one's going to be a +1. This one's going to be a +1 for the y part. And this one's going to be +1, +1. Top left, bottom right. There you go. And now I'm going to get the 2 by 2 window. So in the square tracker that I'm creating, I'm going to add it to. I'm going to get 2 by 2 window with, let's see about this one, matrix and U to D. Wait, hold for a second. X position, Y position. I don't want to mess this up. This one has to be L to D, and this one's going to be U to D. There you go. All right. And after that, I'm going to return. I'm going to make this much easier for you guys to follow. I'll put this right here. There we go. Now we'll return the hash set size of this, and that's going to be the size of the hash set square tracker.size, and that's going to be the number of different equations into this one. I think this should work. If I walk through it, it should work, but if I just run it, I think it should pass anyways. Unless there's syntax errors. Oh boy, ah, it set up integer should be string. Dang it, I should be more careful. You guys, you know, in your interviews, you always have to walk through your code verbally before you run it. It should be good. Uh-oh. And I think I should have followed my own advice. What did I do wrong here? Alright, I know why I did wrong. You guys see this right here? I switched this. I switched this on accident. Dang it. It's going to take forever for me to fix this thing. Hold for a second, guys. Alright, so since, you know, I'm kind of used to making X and Y because, you know, all my elementary experience is always putting X here, Y here, but in terms of this way, there you go, it passes. Okay, so I accidentally switched the XY values for the matrix. Remember, the first index is going through each row, so that's why it's going up to down. And X position is going left to right through each value within each row. This is why it has to be framed this way. Alright guys, I hope you like this question. Please like and subscribe if you'd like this solution, and if there's a better one, feel free to comment below and I'll pin it if I think it's much better than the one I provided. This one seems like it's going to be about ON squared time complexity. The space complexity is about, since it's going to be a hash set with a number of different squares, worst case scenario, it should probably be about almost around ON squared as well, because you're going to go find a solution from here to here. We know it's going to be like ON minus 1 squared, basically. Worst case scenario, it's rounded out to be about ON squared. Alright guys, thank you for watching. If you like and subscribe, I'm going to give you Keanu Reeves. He's going to guide you to the matrix like as soon as you take the red pill and subscribe, hit the red subscribe button. He's going to take you down the rabbit hole and show you the underlinings of the simulated world that we live in. No, just kidding. You guys have a good day. Goodbye.